is group 19 and my name is Yasin. So we are doing for lab 2 digital electronic design. So I will discuss about part 1. Using the 74SC 74D type flip-flop, this one. So we are able to make input and the clock to prove here. So when there's nothing in D or at the clock here, so there will be no output as shown here. As for this one, if this one is on, this one is off. If this one is off, this one will indicate on. So when I try to press only for the D, that is the input, so you see there's nothing there, so it's true. So when I try to press for the clock, it should be on. Yes, this one is on, this one is off. So when I press for both again, it's on, and then when I try to off one of it, it's still on, the clock off, on. Okay, and then when the input is off and the clock is off, and then it's still on, true. So when the input is off and the clock is on, it will off. And then when the input is off is this one, so it's still off, so it's true. And if I try to input 1 and 0 for the clock, it will show no output. And then when I off for the input, make it 0, and then 0 clock, it will stay for 0. And then when I try to press for the input, and then 0 for the clock, it will still stay off. But when I press for clock, it will on. So that is for part 1. Thank you. Hi. So I'm going to talk about part 1 at this part, the temper switch. So what is temper switch? First of all, temper switch usually used in a sprinkler system. So this flow switch will work together with the temper switch here in a sprinkler system. So this temper switch usually used with a flow switch, but temper switch usually activate when there's a trouble signal are being produced. And the second example is the temper switch are also used inside a security alarm equipment. There's a temper switch that are built inside that alarm security equipment. So this security alarm equipment have a built-in temper switch inside of it to prevent it from being tempered. So if someone are about to tamper with the alarm itself will make a noise. So generally speaking, a temper switch are used to generate or trigger a signal if something unfortunate happen to the system or temper switch itself. Answering question number 2. Does the circuit follow the temper switch? Yes. Why? Because assume that this LED will indicate an on signal or triggered signal. This LED will indicate an off signal or non-triggered signal. As for this one, will indicate an on or D on circuit. And this one will indicate the temper or clock. So for example, so this circuit or temper switch are currently in off state. The switch is currently being on, so there's still no triggered signal are being generated. But when it is being tempered, boom, a triggered signal are being generated. So when someone try to off the switch, it will still remember that the circuit are currently being tempered, thus trigger signal are still being generated. To make the triggered signal being turned off, someone authorized must first off the tempered LED. Now it is currently on 00 and still on, 00 and then still on, because the circuit still remember that just now it is currently being triggered, but now it's not, but it still remember triggered signal are still being generated. To make the circuit into an off state or non-generated signal, a person must trigger back the temper LED or the temper signal. Here is the temper signal. So when I press it, temper switch will be in off state. 1, 2, 3. and the cycle continues on as the switch are being turned on. That is how this circuit, D-type flip-flop, are the same with the temper switch. And this is how we use D-type flip-flop in temper switch. That are the third question, and I hope this will answer all of the 3 questions that are being asked by Dr. Hermawan. Signal being generated, still remember, and then try to off. Yes, press this one and 2. Signal generated are being off. This is all for part 1.
My name is Jackson Han. I'm from D.E.D Digital Electronic Designs, Group 19. Currently doing Lab E2, and I'm in charge of explaining part 2. So for the circuit, we have just changed compared to part 1. We have just switched from the input module to the clock module and set it at 500 kHz, whereas the connection still remains the same here. And the expected waveform, we have wrote 250 kHz, as you can see here. When we're reaching the uprising edge of the clock value, there's a change in Q. Let's see. Here, from here to here, it's 500 kHz, which causes the clock value to change. See, it's going down. And as stated, it's 250 kHz for the value of Q. Thank you very much.
Jasin here, I'm going to talk about the part 3 of our D.E.D Lab 2. As you can see, it is asked to use the HC161 to create a counter which counts from 1 to 6. And this is our real logic. And this is a real circuit. And as you can see inside this data sheet, it will only count when CP is up, CEP is high, and CET is high. In this case, in our circuit, we have said that CET is always high. Only our CEP will change from high to low. When it is low, it is whole. When it is high, it is count. Yeah, so you can see here. So when there is no input, it will hold. Where the CET, I mean CEP, when the CEP is high, it will start counting. 1, 2, 3, 4, 5, 6, and back to 1 again. So if I change my CP to low, it will just hold. Yeah, and that's it. Hey, it's JC again, and this time I'm going to talk about part 4 of our D.E.D Lab 2. In part 4, we are asked to create a dice which looks like this, and this is the logic of it. So for the circuit, we use the same circuit as just now. It's just that we changed our output from this normal LED module to this die module. So as you can see, it still works the same. When CP is high, it will start counting 3, 4, 5, 6, and then back to 1, 2, 3, 4, 5, and 6. So when it's 0, it will hold, just like the part 3. Yeah, and that's it. For the last part of Lab 2 D.E.D, which is combine part 3 and part 4, yeah, which is here, combine part 3 and part 4. So this is the circuit. Come, let's look at the circuit. Say 1, 2, 3, 4, 5, and 6, and then back to 1 again.
3, 4, 5, 6.
Yeah. If it's 0, hold. Perfect.